Welcome to Global Future School. Students, this is your first year chemistry class. I'm Dr. Jadvano, and the topic for today's discussion is very important. That is limiting and non-limiting reactant from chapter 1. First year chemistry, chapter 1 is the stoichiometry. And the topic for today's discussion is, again I'm repeating, it is limiting and non-limiting reactant. Students, after completing this topic, you will be able to identify the limiting reactant and non-limiting reactant in a reaction, and you will be able to calculate the maximum amount of the product that produced and the amount of any unreacted excess reagent. Students, this topic you can't understand without understanding the topic about the mole. So I was focusing on when I was giving a lecture about the mole. So you have to go through again about the topic mole. What is mole, how to calculate the mole, how to convert mole into mass and mass into mole. So first you have to clear the understand you have clearly understanding of the mole, about mole topic, then you will be able to understand limiting reactant. So this limiting reactant is not only just about this topic. So before going this into detail of this, you must have to recall the mole, Avogadro's number, molar volume, and then you will be able to completely understand about the limiting and non-limiting reactant. And again, before going into the detail of the limiting and non-limiting reactants, I must recall you about the reactant or reactants. When a chemical reaction or whenever a product is formed, the ingredients that is used to make a product, that are called the reactant. If they are more than one reactant, then they are called the reactants. For example, in this case H2O water, this is our product, and this is formed with the help of hydrogen and oxygen. So hydrogen and oxygen, these both are reactants in this case. Formation of carbon dioxide, that is formed with the help of carbon and oxygen. So carbon and oxygen, they both are reactants. Similarly, formation of sodium chloride, that is a table salt. So that is formed with the help of sodium metal and chlorine gas. So these are the reactants. Similarly, formation of any product in kitchen, that the ingredients that are used to form like burgers or cheese sandwiches or something else. So that ingredients that are used to make the final product, those ingredients are called the reactants. So hopefully reactants are now clear. Then what is limiting reactant? One thing you must clear, limiting reactant concept is applied where reactions involve more than one reactant. So because if there is one reactant, that will be the just reactant. When that reactant will completely used, the product will be formed. But in case of when we have more than one reactant, some reactants consumes earlier, some reactants remain unused or unreacted. So this basically applied for those reactions that involve more than one reactant. So this can be defined in different ways. The reactant that is completely consumed, that is completely used during a chemical reaction. So in a chemical reaction, when one reactant that is completely consumed, completely used, that reactant will be called limiting reactant. So focus on the word limit. Limit just control. If this is finished, then the reaction is done. So limiting reactant is the reactant which completely consumes during a chemical reaction, or reactant which produced least amount of or least moles of the product. So that reactant which produced minimum amount of the products, because when that is completely consumed, so the product form, there will be no further product formation. So that will also called limiting reactant. Or you can say reactant which control the amount of the product or which control the reaction, because when one reactant is completely consumed, no more product will be formed. So basically that reactant is controlling the amount of the product formation, that is controlling the reaction, that is called the limiting reactant. For example, we have like combustion you mean in burning in the presence of oxygen, combustion of candle or combustion of petrol. So in that case, when a petrol is burned, petrol in the presence of oxygen, combustion occurs. So petrol and candle, these are reactants, and oxygen is also reactant, and this they produce heat, carbon dioxide and steam. So heat, carbon dioxide and water vapors, they are the products. So in this case candle will be consumed earlier, or if petrol will be consumed earlier, but oxygen will be everywhere. So that consumes earlier, that that control the amount of product formation, that is limiting reactant. Let's see this example. This is like a candle, this wax is used as a fuel. So we have two reactors here, oxygen and this candle wax. This we have two reactors and they are producing heat. So heat is our product, carbon dioxide is our product, and steam, H2O in the form of gas, this is our product. So when you know, when this fuel or wax will be, candle will be completely consumed, there will be no further heat production, there will be no further carbon dioxide production, there will be no further steam production. So basically this is limiting the amount of product formation, and this is consumed, completely consumed, this is consuming earlier. So this is the limiting reactant, and the other one will be the excessive, because oxygen is still there, exists. So limiting reactant is the reactant which consumes earlier, which consumes completely, which limit the amount of product formation. Hopefully students, limiting reactant is now clear to you. So the other reactant will be called non-limiting reactant or excessive reactant, because that is more than the other reactant, that is excessive reactant. So you can define this: reactant that left unused during a chemical reaction is called non-limiting reactant, or the reactant that left unreacted, that is still present in the reaction mixture but it cannot produce the product, that will be called non-limiting or excessive reactant. Or the reactant which do not control the amount of the product, because the one that consumes earlier, that is actually controlling the amount of product formation, so that is limiting. And but that is not controlling, that is still in the reaction mixture but it cannot produce the further product, that is a non-limiting or excessive reactant. So again example, in combustion of candle wax or petrol, oxygen is non-limiting. Here is again an example. This is the candle, so this is reactant and oxygen, they are producing heat and carbon dioxide and water. So this is consuming slowly. The stage will come there when there will be zero candle, so this is consumed completely, but oxygen is still there. So this oxygen is non-limiting excessive reactant, and this candle wax or petrol, these are the limiting reactants. So hopefully limiting and non-limiting reactants and their difference is now clear to you. Now how you can identify the limiting reactant? So this is very important and this is very easy, but if you know, if still I'm telling you that if you don't have the concept of mole, you cannot understand this topic. So go through the mole topic again, and then understand this. How can we can identify the, these are the general example, combustion of like candle or petrol. We can observe that petrol consumes completely, candle consumes completely, they are limiting. But if we have a reaction mixer, we have different chemicals, then how we can identify the limiting reactant? So for that we have the steps. First of all, calculate mole of products from given amount of the reactant. This reactant amounts can be in the form of mass or can be in the form of moles. So if this is in the form of, given you in the form of mass, then first convert them in the form of moles. Then with the help of these moles, the second step, reactant with the help of moles, find the mole of products. So first amount of reactant that is given you, either it is in the form of mass or in the form of moles. If it is in the form of mass, first convert them into moles. Then with the help of moles of reactant, calculate the mole of the product. Then second step, now observe which reactant is giving least moles of the product, that will be the limiting reactant. The reactant which giving more moles of the product, that will be excessive. So now this will be clear. I am giving you example. 10 moles of H2. First of all, write the data. So you have given the moles of H2, that is 10 moles. Even if they gives you in the form of mass, then convert them into moles and then write here 10 moles. And moles of oxygen, they are given you 7 moles. So first step, calculate mole of product. Which product we have? H2O, with the help of reactants. So first of all, we have two reactants, H2 and O2. Write the balanced chemical equation. You know, H2 plus oxygen, it gives you H2O. So this equation is not balanced. First of all, balance it. So 2 oxygen and now 4 hydrogen. So equation is balanced. And the step apply, calculate mole of product. Write the product on your right side with the help of reactant. So first, one by one. First reactant is H2, so we will calculate the moles of H2O reactant with the help of H2O product with the help of H2 reactant. So first, from balanced chemical equation, so B stands for balanced chemical equation. Balanced chemical equation shows when 2 moles of hydrogens are consumed, then 2 moles of H2 are formed. So when 1 mole will be consumed of hydrogen and 1 mole of hydrogen H2O, water will be formed, because 2 divided by 2. When we have this 10 moles, when 10 moles of hydrogen consumes, then H2O formed will be again 10 moles. So these are moles of H2O. Now calculate mole of product with the help of other reactant. So again, H2O on your right side, oxygen on your left side. So from balanced chemical equation shows when 1 mole of oxygen is consumed, then 2 moles of water are formed, and when 7 moles of oxygens are consumed, then how many moles of water will be formed? 2 into 7, that are 14 moles of H2O. So it means when 10 moles of hydrogen will consume completely, then 10 moles of H2O will be formed. When 7 moles of O2 will consume completely, then 14 moles of H2O will be formed. So in this case, you can see which is giving less moles. That is the hydrogen. Hydrogen is giving less moles of water. So this is the limiting reactant. So limiting reactant will be H2. Then other will be non-limiting or excessive reactant, that is oxygen. So now this is clear that H2, because it is producing least moles of H2, it will consume earlier, so it will be the limiting reactant. Now we will understand how to identify the limiting reactant and non-limiting reactant or excessive reactant, how much excessive reactant is left, with the help of this example. This is a solved example from your chapter, but here I am calculating for you just to make you clear about how to identify the limiting reactant in a reaction. So the question is 200 grams of K2Cr2O7, that is potassium dichromate, were reacted with 200 grams of sulfuric acid. Calculate two things: mass of the atomic oxygen produced and the mass of reactant that is left unreacted. So mass of non-limiting reactant you have to calculate. First of all, the equation is given you. This is a balanced chemical equation. Again, I am telling you balanced chemical equation, and you must recall about the reactant ratio, reactant product ratio, because that all from the moles and mole ratio. That concept is now we are applying on this in this example. So first of all, because now we are starting from a back step. In identification we told that moles of reactant, but now we have given the mass of reactant. So first convert the mass of reactants into moles. So first step is convert mass of all the reactants into their moles. So here are two reactants, two types of reactant, and their mass is given. So first step is convert them into their moles. So, and the formula is applied: mass in gram divided by molar mass of that substance, that will give you moles. Mass of potassium dichromate is given 200 gram, and its molar mass you have to calculate. And potassium, you know, it's 39 molar mass, and here are 2. And chromium, its atomic mass is 52, and there are 2. And plus oxygen, you know, its mass is 16, and here we have 7. When you add all these, it comes out now 294 grams per mole. So mass in gram is given 200 gram divided by 294, and this gives you 0.68 moles of potassium dichromate, K2Cr2O7. So first we have converted this mass into moles, and now convert this also into moles. So again, mass in gram divided by molar mass of sulfuric acid, H22 plus sulfur 32 plus 4 oxygen 64, it gives you 98. So this is 2.04 moles of H2SO4. So first step is like you have converted. If you have given an other reactant, again convert that also into the moles. So first step, convert all the reactants mass into moles. So first step is done. Now calculate the moles of product with the help of moles of reactants one by one. So this here we are applying more like reactant product ratio. Again, this is calculated from its mass, that is given 200 gram, and this is also calculated from its mass that was given 200 gram of H2SO4, and this is balanced chemical equation. This is very simple. You have to calculate the moles of product, that is oxygen, atomic oxygen. So you have to calculate the moles of this oxygen. Write this on your right side, and first with the help of first reactant, that is K2Cr2O7. So first of all, from balanced chemical equation telling you when 1 mole of potassium dichromate is consumed, then 3 moles of hydrogen are formed. When 1 mole is consumed, then 3 moles are formed of oxygen. When 0.68, that 0.68 from 200 grams, then it will be 3 into 0.68, and answer is 2.04 moles of oxygen, that is in atomic form. Now calculate moles of oxygen with the help of other reactant. So moles of oxygen with the help of other reactant, that is H2SO4. So from equation is telling you when 4 moles of sulfuric acid consumes completely, then 3 moles of oxygen are formed. When 1 mole is, then it will be 3.4, and 2.04 of sulfuric acid. This comes from where? These are all values from H2SO4. Then it will be 3 by 4 into 2.04, and our answer is 1.53 moles of oxygen. So here two things. Oxygen from K2Cr2O7, it produces 2.04, and oxygen from H2SO4, it will be 1.53. So when H2SO4, 200 gram of H2SO4, that form 2.04, when this completely consumes, then oxygen will be formed only 1.5, it will be completely consumed. But when K2SO4, it will form 2.04, it can maximum form 2.04. So when this will be consumed completely, then it will remain unreacted in the reaction mixture. So you can easily identify that producing less moles of product, because H2SO4 is producing less, 1.53, that is less than 2.04. So this will be limiting reactant. Then what will be the excessive, a non-reactant, non-limiting reactant? Of course, that will be potassium dichromate. So now, because sulfuric acid is producing 1.53 moles of oxygen, So calculation of product will be on the base of calculation from limiting reactant. So limiting reactant is given 1.53. This will multiply with this atomic mass, that is oxygen's atomic mass is 16. It will give you 24.4 gram of atomic oxygen. So it means when you mix 200 gram of potassium chromate, 200 gram of H2SO4, the maximum oxygen that is formed will be 24.4 gram of atomic oxygen. Now the second question asked is how much non-limiting or excessive reactant left unreacted. That is very easy. Again, now you have to calculate the potassium K2Cr2O7. So these are the same ratio. I will calculate again just for your simplicity, like, because we have to calculate the excessive. Excessive is K2Cr2O7 with the help of non-limiting, that is H2SO4. And you know from equation, balanced chemical equation, when 4 moles of sulfuric acid, these are the same calculation, then 1 mole of K2Cr2O7 consumes. When 4 moles of sulfuric acid consumes, then at that time only 1 mole of K2Cr2O7 is consumed. When it's 1 mole we consume, then it will be 1/4, 1 by 4. And 1, when H2SO4, the total mole of H2SO4 that were from 200 gram were 2.04. 2.04, then how much of K2Cr2O7 will be consumed? Then answer is 0.51. This is the same calculation like this one. So when sulfuric acid's mole 2.04 consumes completely, at that time only 0.51 moles of K2Cr2O7 will be consumed. But originally total moles were 0.68 and the consumed are 0.51. So left will be, you have to minus it, that will be 0.17 moles that remain in the reaction mixture. These are the moles of potassium dichromate K2Cr2O7. So these are the unreacted moles. So now we have to find its mass. Very simple, convert its mole by multiplying it with its molar mass. Potassium dichromate molar mass we have just calculated, that is 294. So 294 multiplied by 0.17, answer is 49.98 gram, or you can say 50 gram. So what it means, when 200 gram of H2SO4 and you mix 200 gram of K2Cr2O7, so total this consumes completely, and this consumes, because 50 is left, so then it will be 150 consumes. It consumes completely. At that time potassium dichromate consumes 150 gram, because 50 gram is unleft, that is unreacted, unused. Hopefully now this is clear. You can given you any question, the steps you have to follow. First of all, convert mass into moles, all of the reactants mass into moles. Then with the help of moles of the reactant, calculate mole of the product. Then identify which reactant is giving you the less moles of the product. On the base of that, calculate the mass of that product. Then you have to calculate the unreacted. So compare the limiting and non-limiting reactant and find the consumed. So first consumed, then minus subtract it from the total moles, and the subtracted value that are unreacted left moles, convert back them into the mass. Then you can find, in this way you can find out the unreacted excessive amount in this way. Hopefully this is very clear, and for your practice please solve the example 1.7 and 1.8. The questions usually can be asked about define limiting, define non-limiting, compare it, give examples, or the question can be concept of limiting reactant. This is a short response question, SRQ, and its mark are 3 marks for each short response question. Concept of limiting reactant is not applicable to the reversible reaction. So first you have to understand what is reversible reaction. Reversible reactions that goes forward as well as the reverse. So at the some stage product convert back into the reaction. So those reactions never goes to completion. But in the case of limiting reactant, we said that one reactant consumes completely. So the concept of non-limiting reactant is only applicable to non-reversible reaction. It is not applicable to the reversible reaction. Because again, differentiate between limiting and non-limiting reactant. Then the question is given, calculate the weight of oxygen. Weight means mass of oxygen. Mass can be in gram or kilogram. And when involved, when 5 kilogram of KClO3 are completely decomposed. So here KClO3 is completely decomposing. So I am giving you equation and the step you have to calculate by yourself. Equation is KClO3 thermally decomposed, means on heating it decompose into KClO and oxygen. So you have to calculate the mass. You have given the mass of KClO3, that is 5 kilogram. First of all, convert this into gram. So multiply this into with 1000. You will its mass will be converted into gram. Then convert it into moles. So this is very important, because with the help of mole-mole ratio you can calculate easily. With the help of mass you cannot calculate directly the mass of the reactant or other product. So with the here you will find the moles of KClO3. So compare these moles with the help and oxygen's mole and calculate here the moles of oxygen. So then with the help of these moles, convert these mole into back into mass by multiplying with this answer with 16. Then you will find the mass in gram of oxygen. Even you can go and convert them into kilogram by dividing this mass. So basic steps are convert kilogram into gram, then gram into moles. With the help of moles, find the moles of oxygen by a ratio method, and then convert the oxygen moles into mass, and again from gram to kilogram you can calculate. This step is optional. Hopefully now this is clear, and you can solve any type of the question, any type of the numerical problem when you have the understanding of mole topic and then this limiting non-limiting steps. So this was all about limiting reactant, non-limiting reactant, their definition, identification and the calculations. And our next topic will be different types of yields, that are theoretical yield, actual yield and percentage yield.